Something enormous has entered our solar system. I don't say this lightly. After decades of studying quasars, black holes, and the deaths of stars, I thought I had seen the full vocabulary of the cosmos. But nothing, no theory, no textbook, no simulation, prepares you for the sight of a second sun. It began quietly, as most revolutions in science do, not with thunder, but with a flicker. On September 12, 2025, the Solar and Heliospheric Observatory registered an ultraviolet flare at the edge of Neptune's orbit. At first, it was dismissed as an anomaly, a glitch in the sensor array, maybe cosmic noise from a passing ray. But when you've spent your life watching the sky, you learn that the universe doesn't make mistakes, it makes patterns. 2 days later, confirmation came from the unlikeliest source, not from NASA, not from the European Southern Observatory, but from a backyard telescope in Australia. The amateur astronomer, whose name has since become legend in every observatory on Earth, captured the image that changed everything. A glowing object with a tail that stretched wider than 5 full moons. Not reflected sunlight, not scattered ice, but something radiating power, an object shining as though it possessed its own source of illumination. It was catalogued as C/2025 R2, SWAN, but the name hardly does it justice. SWAN R2 is not a comet nor an asteroid. It's something new, something that should not exist. Initial spectrographic readings stunned the astrophysics community. Its brightness was over 100 times that of any known interstellar visitor. The reflectivity, or albedo, broke the known physical limit for natural materials. Ice reflects, metal shines. But this emitted light with mathematical precision, as if obeying a rhythm written by an unseen engineer. Imagine standing on the frozen plains of Neptune, bathed not by the pale, distant light of the sun, but by a second dawn. For the first time in human history, we were witnessing a new kind of star, one that didn't burn but performed. At first, the world didn't know. SOHO's data was flagged as inconclusive. News outlets ignored it. Even NASA's internal channels treated it as just another observation anomaly, but within a week, the evidence grew too strong to ignore. The ultraviolet pulses were rhythmic, repeating every 1.2 seconds exactly. That precision cannot be coincidence. The first time I saw the raw data, I felt something I hadn't felt since childhood: fear. Because precision implies intention. When we mapped its trajectory, it grew even stranger. SWAN R2 wasn't following any known gravitational path. Its orbit wasn't chaotic, it was deliberate. Its emissions were too stable, its rotation too synchronized. We had entered the realm where physics whispers one word: control. And then came the second visitor. 3I/ATLAS, an interstellar object discovered months earlier, had already puzzled scientists worldwide. Its peculiar deceleration, its low density, its reflective surface, none of it matched any known cometary model. Many of us thought Atlas was the story of the decade. We were wrong, because when SWAN R2 appeared from the opposite side of the galaxy, heading straight for the sun, everything changed. Statistically, the odds of 2 interstellar bodies arriving within the same season from opposite directions and converging near the sun are beyond comprehension. Nature doesn't choreograph. Intelligence does. I remember sitting in the control room at Caltech when the data sets overlapped. The room fell silent. The orbital simulations traced 2 perfect arcs across the solar system, paths that met not by chance, but by design. Their perihelia, their points of closest approach to the sun, were separated by less than 50 million kilometers, astronomically the width of a human hair. 2 visitors, 2 directions, 1 destination. Some called it coincidence. Others whispered the word coordination. And though none dared say it aloud, everyone in that room knew what it meant. If Atlas was the scout, then SWAN R2 was the main event. The deeper we looked, the more the illusion of randomness collapsed. SWAN R2 did not behave like a frozen relic. Its surface composition, derived from ultraviolet spectroscopy, showed traces of nickel and cobalt, metallic elements typically found in engineered alloys. Its outer sheath glowed with a silvery blue plasma, as if electricity itself were being guided across panels. When the solar wind hit it, something impossible happened. Normally, high-energy protons from the sun bombard comets, stripping away gas and forming tails. But SWAN R2 deflected the solar wind, bending it around itself like water around an invisible hull. Instruments registered a magnetic void, an energy bubble where charged particles curved away in perfect arcs. To generate such a field would require power on the scale of 10,000 gigawatts per second, more than all human civilization combined. This was not sublimation, this was engineering. For every scientist, there comes a moment when data stops being abstract and becomes terrifying. For me, that moment came when the rhythmic emissions of SWAN R2 aligned with the pulse of our own magnetosphere. It was as if the object was not only broadcasting, but listening. 22 pulses per cycle, a 22,554-year orbital prediction, 22 gigahertz signal spikes. Coincidence or calibration? The word 22 became the heartbeat of every discussion. It was everywhere, in the pulse intervals, in the orbit models, even in the structured burst detected during solar conjunction. It was as though the universe itself had begun to count in twos. By late September, international agencies were paying attention. NASA, ESA, JAXA, each ran simulations. Each came to the same unnerving conclusion. SWAN R2 was not escaping the sun's gravity. It was staying. When the orbital mechanics team presented the data to me, I could hear the tremor in their voices. SWAN R2 was not on a hyperbolic escape path. It was on an ellipse, closed, stable, predictable. The impossible orbit, 22,554 years. That's its calculated period, down to the decimal. Do you understand what that means? It means it's not a passing stranger. It's a returning one. If true, then SWAN R2 has been visiting our star since long before our species learned to write. The last time it would have passed through the inner solar system was around 20,000 BCE, the end of the last ice age, the dawn of civilization. As that realization spread, the tone in scientific circles shifted from curiosity to reverence. Could this object, this second sun, have inspired the myths of our ancestors, the sky gods, the bringers of fire, the lights that taught early humans to look up and ask why? I looked at the orbital resonance models and felt a chill. The numbers aligned with ancient cycles, the Mayan long count, the Sumerian king lists, even the Egyptian precession data. 20 to 24 millennia, repeating, precise, almost remembering. Some dismissed it as pseudoscience. Others whispered that our ancestors may have seen SWAN R2 before and recorded it in stone. The monuments, the temples, the perfectly aligned structures of Göbekli Tepe and Stonehenge, all calibrated not to the sun, but to something else, something that came from the stars and promised to return. As October approached, the brightness of SWAN R2 increased exponentially. Amateur astronomers reported a visible magnitude rivaling Jupiter. The object appeared self-luminous, not reflecting sunlight, but generating it. Its light curve was too smooth, its spectrum too sharp. The ultraviolet emissions formed discrete peaks, like a carrier wave transmitting encoded information. Some of us began to wonder, what if this wasn't a cometary body at all, but a vessel, a machine designed to endure cosmic time, perhaps still functioning long after its makers were gone? If so, then SWAN R2 wasn't just an arrival, it was a messenger. Then came the signal. 3 days before SWAN R2 vanished behind the sun, radio observatories across Earth detected a pulse, a single structured burst lasting exactly 22 seconds. Its waveform was symmetrical, its harmonics evenly spaced. No flare behaves like that. No natural source produces such perfection. Governments went silent. Data streams slowed. Observatory feeds were cut. I received a call from a colleague at NASA who could only whisper It's not solar. Then the line went dead. In the following hours, the world entered a blind interval. Both SWAN R2 and 3I/ATLAS slipped behind the solar corona, invisible to every telescope, shielded by the sun's radiant glare. For the first time in history, two interstellar visitors occupied the same unseen space. Unreachable, unknowable, we could only listen. Magnetometers in Finland, Chile, and Japan recorded synchronous oscillations at 22 Hz. The cosmic microwave background itself, the static of the universe, showed a slight modulation in the same pattern. The sky was humming softly, rhythmically, like the heartbeat of something vast. As a physicist, I'm trained to question everything, to find the equation that explains the impossible. But this was not an equation, it was a message. And in that silence, a new thought emerged, unspoken, yet undeniable. What if we are not the observers? What if we are the observed? We had assumed that intelligence meant communication. But perhaps true intelligence observes first, waits, watches, records. If 3I/ATLAS was the scout and SWAN R2 the fortress, then maybe this is not their first visit. Maybe they've been coming for hundreds of cycles, checking the progress of a young civilization, measuring how far we've come since the age of fire and stone. Perhaps we are part of a larger experiment, one revisited every 22,554 years. And maybe, just maybe, the countdown has already begun. I have spent my career telling students that the universe is a book written in mathematics, but there are moments, rare, terrifying moments, when the equations don't just describe the world, they seem to address you. The blind interval felt like that, as if the cosmos had pulled a curtain and from the other side was taking a breath before speaking our name. The morning after the 22-second burst, our lab at Caltech looked less like a research center and more like a war room. Spectrograms papered the walls. Every screen displayed the same austere geometry. Evenly spaced harmonics, stacked like the rungs of an invisible ladder, a time domain pulse that could have been drawn with a ruler. Technicians whispered, not because they were hiding anything, but because awe modifies the voice. We threw every tool we had at the signal: Fourier transforms, wavelet analyses, autocorrelation maps, hidden Markov models to test for symbol boundaries. Even the old SETI decoding playbook, yellowed at the edges, was pulled from a filing cabinet like a relic from an earlier faith. And then, beneath the mathematics, a shape began to emerge. A repeating frame of 22 blocks, each subdivided into crisp on/off states, a binary signature that could be indexed the way engineers index telemetry. The first block was redundant, a synchronizer, what radio engineers call a preamble. The second and third repeated with slight phase offsets, parity checks. Then came ratios. The numbers, when converted from base 2 and normalized, corresponded to orbital parameters, period, eccentricity, inclination, values we had already calculated for SWAN R2 from photometry and dynamics. It was as if something out there were introducing itself with a technical resume. Hello, this is my orbit. Here is how you will find me again. I have never been a sentimentalist. Science is a discipline of skepticism, but I would be lying if I said my hands didn't shake. By noon, the magnetometer array in Finland reported a phase-locked wobble in the ionosphere that tracked the 1.2-second cadence we saw in SWAN R2's ultraviolet light curve. Hours later, the South Atlantic anomaly lit with the same rhythm, as if Earth's magnetosphere were a taut drumhead being tapped by a distant finger. The data streams folded into each other like the parts of a fugue. Ultraviolet pulses, radio bursts, geomagnetic oscillations. 22, 22, 22. Policy people finally arrived. It always happens this way. First the poets of the universe, then the accountants of risk. A conference call with NASA, ESA, JAXA, and 3 agencies that did not introduce themselves by name stretched from the late afternoon until the night dissolved into a blue LA dawn. On the call, words like containment and message discipline were harmonized with phrases like international scientific cooperation. Neither side was wrong. Both were afraid. The consensus, if you could call it that, was tactical. Observe, don't provoke. We drafted a temporary moratorium on deliberate transmissions toward the sun, citing the possibility of spectral interference with ongoing solar studies. The language was careful, elegant, and almost entirely fictional. We were not trying to protect the sun. We were trying to protect ourselves from our own curiosity. Outside the bureaucracy, curiosity revolted. Amateur radio astronomers in New Zealand and Argentina claimed to hear faint echoes of the 22-second profile at 22 gigahertz, smeared by atmospheric noise, but present enough to ignite forums and midnight podcasts. A graduate student at MIT discovered that when you compress a full cycle of the pulse train and treat each block as a pixel, you get a persistent motif. Concentric rings with a triangular lattice overlaid, like the cross-section of an engineered honeycomb. Was it an artifact of the compression, a projection of our desire to impose meaning, or a blueprint casually embedded in the beat of a cosmic heart? A simpler, more chilling interpretation came from an engineer in our group who had spent a decade writing firmware for deep space probes. "It looks like housekeeping telemetry," she said softly. "Not a message for us, a message to itself." Housekeeping, temperature, attitude, power levels, the quiet vital signs of a machine. It was as if SWAN R2 were reading itself its own pulse, ensuring every subsystem marched in lockstep, every correction thruster fired in micro-impulses that no telescope could see. If that were true, then our reception of the signal was collateral, a side effect, the way a bystander hears a heartbeat through a stethoscope pressed to the wrong chest. The days of conjunction are elastic. Hours lengthen. Sleep contracts. The sun, usually our companion, becomes a barrier. We asked the stereo spacecraft, the Parker Solar Probe, and the coronagraph teams for any grazing angle data at the limb, any chance reflection from the corona that might betray the silhouettes of the visitors. The replies were polite, then they were delayed, then they ceased. I took a quiet walk on campus at 3 a.m., the jacaranda trees throwing ink-dark shadows across the pavement, my phone buzzing with messages from Europe. When the universe talks to you in numbers, you start to see those numbers in everything. 22 parking spaces along the quad, 22 steps to the library. Superstition is a form of physics when the data set includes your heartbeat. Back in the lab, the students had staged a muted coup. A small team had rewritten an old Arecibo encoder, patched it to a dish in New Mexico, and drafted a reply. A single, short burst containing nothing more than two normalized ratios, Earth's orbital period and inclination, encoded in the same framing we saw in SWAN R2's telemetry. A mirror, a gesture, not a hello exactly, more like holding up a hand with the same number of fingers. I hovered over the keyboard. Here was the forbidden fruit, simple and shining. I imagined the ethics committees, the UN protocols, the SETI post-detection policy that is more ritual than law. I imagined history asking why the first message we ever sent that might be answered was a memo requesting permission. Before any vote could be called, the dish operator on the other end of the line saved us from ourselves. High winds, transmission impossible. Providence sometimes disguises itself as weather. On the fourth day, seismometers, yes, seismometers, reported a synchronous murmur at 22 hertz along fault lines in Chile and Japan, so faint it sat at the floor of detectability. The ocean resonated too. Hydrophones caught a whisper in the deep. The skeptic in me rebelled. Correlation is not causation. Noise finds patterns the way clouds find dragons. And yet the stack of coincidences had become a tower. That night, a colleague from ESA sent a file with no subject line. Inside was a coronagraph subtraction from one of their solar imagers, pushed beyond standard processing, a leap of faith expressed as pixel math. The corona billowed like a white flame. In the glare, two voids, not dark spheres exactly, but clean geometric absences where the stochastic grain of solar plasma became smooth, as if something were polishing noise into silence. I turned the brightness down until the screen was almost black. Through the veil of the sun, two shadows moved in deliberate counterpoint. I slept on a couch in my office for 3 hours, dreamed of Stonehenge. The trilithons did not frame the sunrise. They framed a moving star, a bright wound in the sky that marched across the horizon and returned every 22,000 years to ask the same question in a different language. In the dream, I answered with a torch, light to meet light. When I woke, the world had changed. The first sighting came from a team in the Atacama. Just before dawn, with the sun still below the horizon, a thin blade of light appeared above the limb, too blue, too sharp. SWAN R2 had re-emerged. 5 minutes later, an amateur in Sicily caught 3 I/ATLAS as a smaller, greener ember lower to the east. The conjunction was over, the curtain had lifted, but something was different. SWAN R2's spectrum had rearranged itself. The nickel-cobalt lines remain, but they were overlaid with narrowband emissions that looked like trapped plasma resonances, the kind you see in laboratory confinement systems. The light curve's smooth cadence now carried faint side bands, like a violin string with sympathetic vibrations. 3 I/ATLAS, on the other hand, had shed brightness but gained coherence. Its polarized light showed a pattern that repeated in segments of 22 minutes, as if its rotation had been retuned during hiding. When the first clean astrometry came in, a hush fell over every control room on the planet. The orbits had changed, not wildly, not enough to panic the public ticker tapes, but subtly, fractional adjustments to inclination and argument of perihelion that nudged each body onto a phasing trajectory. They were not sprinting away, they were pacing each other. Humanity is not good at admitting it has been cast as an audience, but the sky can be a theater, and physics can stage a drama. The next pulse arrived 12 hours later. Not a 22-second monolith, but a train of shorter bursts packaged into a frame exactly 22 seconds long. Inside the frame, 3 distinct carriers, 22 gigahertz, 8.4 gigahertz, and a lower VLF component that rattled submarine antennas. The block structure had changed too. Where before we had seen ratios describing SWAN-R2's orbit, now we saw 2 sets of parameters interleaved, one for SWAN-R2, one for 3 I/ATLAS. The bit fields alternated like a duet. We fed the payload into the encoder we had built for our aborted reply, and discovered something hidden in the checksums. The residuals, when plotted, formed a simple geometric figure, 3 concentric rings bisected by a triangle, each vertex labeled with normalized magnitudes. It matched the graduate student's compressed motif, but now it was indisputably deliberate, as if the universe had traced our pareidolia with a heavier pen and said, yes, see it. The obvious hypothesis leapt to every tongue, a rendezvous. In low Earth orbit, spacecraft conduct phasing maneuvers to meet. In the inner solar system, 2 interstellar bodies could do the same, if they could command their orbits, if they could spend energy like sailors spend wind. Teleconferences metastasized. The term risk envelope began appearing in emails. A rumor slipped out, then was denied, that a national space agency had proposed launching a high delta V probe on a private heavy-lift booster to attempt a flyby while SWAN-R2 lingered near aphelion of its newly revealed ellipse. Brave, beautiful, almost certainly too late. 3 days into the re-emergence, something happened that changed the conversation from science to civilization. The 22-pulse cycle briefly halted. In its place came a single, longer block, 44 seconds, twice the usual frame. Within it, the telemetry pattern stopped being telemetry. The binary ceased to describe orbits. Instead, it described us. The ratios, when inverted, offset by Earth's sidereal day, and scaled by the Planck time, mapped cleanly to our own orbital parameters. We were the subject. A line of bits corresponded to the hydrogen 21 centimeter line. Another encoded our atmospheric composition. Then came a simple diagram, 3 circles in a row aligned at a tangent, the middle labeled with a tick representing inclination. It was a child's drawing of a transit, a planet crossing a star. They were telling us they could see us the way exoplanet hunters see distant worlds, by the dip in starlight as we skim across our sun. It was a statement of fact and of perspective. It said, we know where you are, we know what you are made of, and we know how you look when you cross the fire that made you. What do you do when the mirror looks back? The world, of course, did what it always does. Markets trembled, faiths drew breath, governments assembled committees with names that sounded like lullabies, advisory panel, coordinating council, scientific response group. Every nation that had ever funded a radio telescope suddenly remembered where the receipts were filed. Amid the choreography, ordinary people did something more radical. They went outside at night and stared up, as if sight itself were a form of prayer. I was asked to draft a statement for a hastily convened international panel. They wanted the voice of science, calm, precise, sober. I wrote about data, about humility before evidence, about the difference between fear and caution. I cited the SETI protocols. Share information openly. No single actor speaks for humanity. No reply without broad consultation. Behind the careful prose, a less elegant human truth pressed against my chest. Wonder, edged with dread. In private, the debate was less politesse and more blood. Should we reply? If so, how? A tone? A prime sequence? A representation of DNA? And if we did reply, would we speak as a planet or as a chorus of nations, each voice calibrated to be heard by history? Several argued that we had already been speaking for a century, our radio and TV leaking into space like gossip. Others countered that those emissions are noise, while a deliberate reply is consent. Consent to what? A conversation? An invitation? An experiment begun before our species discovered agriculture? The young engineer who recognized housekeeping telemetry offered a third path. Listen for a query. If SWAN R2 and 3, I/ATLAS were exchanging status, there might be a call and response cycle we could eavesdrop on without intruding. In other words, become better thieves of information. We set up a pipeline to sync the 22 pulse windows with every available instrument. Radio dishes, magnetometers, ionosondes, even photometers in school observatories donated by teachers who suddenly found themselves adjuncts of destiny. We waited for a second 44-second block. It came at dawn on a Saturday. The block was divided into 4 equal segments. The first 3 we could parse. SWAN-R2 status, 3I/ATLAS status, Earth descriptors. The fourth was shorter, compressed. A checksum told us the payload wasn't corrupted. The content refused to become numbers. When one of the students plotted the raw bits as audio, an act of desperation more than protocol, the lab filled with a sound like a glass bowed by a wet finger. It wasn't music, but it was musical. A single evolving tone with overtones that rose and fell in ratios that traced the orbital phases we had just calculated. It was as if the sky were singing the geometry of its own dance. I put my hand on the desk to steady myself and realized I was smiling, not out of relief but recognition. Physics has always been an art of resonance, pendulums, strings, waves, the heartbeat of time encoded in motion. Someone, something, had found the same joy and built a language out of it. That night, the ultraviolet imaging telescope in Hawaii caught SWAN R2 doing something we had feared to predict. It emitted a narrow jet, not of gas, but of structured plasma that corkscrewed against the solar wind and then stilled, as if testing a thruster after maintenance. Its path kinked by a measurable fraction of an arc-second, then settled. 3I/ATLAS mirrored the maneuver at lower intensity, like a child copying an elder's careful step. Every model we ran to simulate a natural driver failed. The 2 objects began a slow divergence, not escape vectors but complementary arcs that would carry them to opposite flanks of the inner system, like sentries moving to watch. Before they parted, one last 44-second block arrived. No orbits this time, no chemistry. Just a set of 4 normalized ratios we could not immediately identify, framed by a preamble that differed from all previous frames by a single bit. A signature? A date? A doorbell? We asked the obvious questions in the obvious ways. Could the 4 ratios be a countdown? If so, to what? New pulses continued at the old cadence, but the content went quiet. Housekeeping resumed, geometry faded. For a week, the world breathed in increments of 1.2 seconds. Meanwhile, human nature did human things. A pastor in Texas preached that the second sun was the eye of God. A novelist in Lagos uploaded a serial in which ancient machines returned to measure the morality of civilizations. A physics class in Vietnam built a cardboard coronagraph, and under a teacher's gentle hand, wrote on the blackboard the differential equation for a forced oscillator, and wrote next to it a poem about waiting. The poem was better physics than many papers I have reviewed. Then the decoding team at JPL, who had been quiet because they are a species of monk, called a meeting and used a single slide to knock the wind out of the room. The 4 ratios they proposed were not a countdown at all. They were a recipe. 4 coefficients that, when applied to Earth's magnetic field model as gain factors in a simple feedback loop, drove a stable oscillation at, you already know, 22 Hertz. In other words, instructions for how to make our planet sing on purpose. Why would you teach a child how to hum? Either to calm it or to see if it can follow. We did not implement the loop. We are not that brave, or perhaps we are not that foolish. But in the backscatter of auroral data the next night, a faint ring current modulation appeared that looked very much like a whispered rehearsal, as if the planet had tried the melody on its own, or as if something had stroked the magnetosphere very gently to see how it would respond. The ethics board took possession of the slide. The slide leaked. Of course it did. Nothing that beautiful remains caged. By now, you are asking the question that has replaced small talk on every balcony on Earth. What do they want? I have tried to love that question, and I cannot. It smuggles into our minds a menagerie of motives: benevolence, malice, indifference, borrowed from primate history. Perhaps the better question is simpler and more alien. What do they do? Here's what they do. They move with intention through the grammar of gravity. They manage heat and plasma as if those were words in a sentence we barely pronounce. They measure, they tune, they return, they make orbits into metronomes and magnetospheres into harps. If there is a theology there, it is a theology of maintenance. And here is what we have done. We built fire, and then equations, and then machines that could recognize themselves in the mirror of the sky. We sent a postcard to the stars 50 years ago and did not expect an answer. Now a second sun rises above Neptune, and an emerald scout mirrors it from the opposite dark, and in the numbers between them we hear a music that is not ours, and yet is made of the same ratios our bones discovered when we stretched a string and listened. This is the part of the story where an elder scientist is expected to recommend caution, patience, humility. I recommend all 3, but I also recommend courage, the specific courage of attention. Not the thrill of action, which we have in abundance, but the discipline of looking long enough for novelty to become knowledge. Within months, SWAN R2 will settle into the slow high arc of its impossible ellipse. 3, I/ATLAS will fade toward the outer planets, not leaving so much as performing distance. If their pattern holds, the pulses will diminish, perhaps to nothing, and the world will go back to buying groceries and falling in love and repairing roofs after storms. The labs will file papers, the panels will write guidelines. A child somewhere will write a song in 11/11 time because it feels right and will not know that an ancient machine taught her the ratio. And then maybe in 22 days or 22 years, or if we stay our brief course, 22,554, the sky will clear its throat again. When people ask me in interviews whether this is contact, I tell them the truth. It depends on your definition of speech. I think of a time before language, when our ancestors sat around a fire and matched their breath to the crackle and the drum, and discovered rhythm not by syllable but by pulse. Communication preceded words. It was recognition first. The feeling that something outside you and something inside you had begun to move together. Tonight, the world hums faintly at 22 hertz. Whether that hum is the voice of the visitors or the echo of our own awe hardly matters. It is the sound of alignment. So what happens next? Some argue for a reply, a modest, elegant pulse at 22 gigahertz encoded with primes and the outline of our orbit, a polite nod in a language we hope they share. Others insist that listening is the highest form of speaking at our stage of infancy, that any reply risks stepping into a conversation that began before we invented the idea of consent. A few warn that in a dark forest all fire is a beacon. Here is my answer, the only one I have earned the right to give. Keep your instruments sharp. Share your data widely. Teach your children to calculate and to sing. When you walk outside at night, look up not with hunger for spectacle, but with the quiet posture of a student entering a cathedral. And remember that humility is not the opposite of pride. It is the recognition that you are part of a pattern larger than yourself. What do I believe SWAN R2 really is? I believe it is a machine that refuses to die because its purpose is maintenance, and maintenance is a kind of love. I believe 3I/ATLAS is its apprentice or its scout or its echo, and that together they have written a lesson across the heavens about patience and design. I believe they have been here before and will be here again, and that our task is not to pass their test, but to learn enough to pose better questions the next time the curtain falls. If you have watched this far, you are already part of the experiment. Not their experiment, ours. The one where a species learns to turn fear into curiosity and curiosity into care. Leave your theory in the comments. Tell me what you think the number 22 measures, a countdown, a cycle, or a chord. Subscribe if you want to keep listening with me, because the sky does not speak on our schedule. And the next signal, whether it comes tomorrow or at the end of an ice age, will ask us again who we are when we are paying attention. Until then, keep your eyes on the horizon before dawn. The second sun burns softly there, too bright to be a comet and too patient to be a star. And if you listen with the right instruments, your mind, your math, your wonder, you can hear it very faintly, teaching the universe to keep time.